Welcome to the SecureDock informational video. In this video, we will explore how the SecureDock systems work, why it was developed, and how it can be integrated into almost any existing online service. The SecureDock is a single-board microcontroller that revolutionizes online security. Its key components are the Arduino Millinova microcontroller, the M-Embedded Systems programming language, Java in combination with the RxTX library, and Google App Engine. For an added layer of security, SecureDock incorporates a 12-button keypad for PIN code verification. Surrounding the keypad are 6 bicolor LEDs, red if the user is not authenticated and green if the user is. The keypad is connected to the Arduino microcontroller via 7 connections and is pulled in a row associated fashion. We will discuss this in more detail soon. Connections 2, 4, 6, and 7 are connected by a 3.5 kilo ohm pull-up resistor. The microcontroller itself is powered by the computer via its USB connection. As previously stated, the keypad is pulled by the microcontroller in a row associative fashion. As you can see, row 1 is powered by pin 2, row 2 is powered by pin 7, row 3 is powered by pin 6, and row 4 is powered by pin 4. Once the microcontroller powers one of these pins, it can easily detect if any of the 3 buttons on this row pass the signal through. If so, the microcontroller notes that button and stores it temporarily until 4 digits have been entered.
You would not believe your eyes.
The SecureDock communicates to the outside world via 2 desktop applications. The first of these 2 programs is called Authorizer. Authorizer allows an administrator to program any of its employees' SecureDocks remotely from online. The reason for this approach is that this implementation allows future updates to enable distributed authorization to a collection of SecureDocks, all remotely from one machine. Let's take a look at how Authorizer works. First, the user plugs in their SecureDock to an internet-ready machine. Next, the user begins the Authorizer device driver application. This application simply acts as a middleman between the microcontroller and the Google Cloud. It essentially opens up the COM port the SecureDock is connected to for receiving incoming byte streams from the Google Cloud. At this point, the computer and the SecureDock are communicating effectively, and the SecureDock is ready to be programmed. The SecureDock will now signal the Google App Engine memory cache via a 32-bit serial value that it is ready for data. This is where the SecureDock administrator will enter the authorization data for that particular SecureDock. On submit, a servlet running on the back end of the SecureDock server will format the data to be stored in the microcontroller's electrically erasable programmable read-only memory, from here on out referred to as the EEPROM. The second application is SecureDock, and like Authorizer, acts as a device driver. SecureDock is much more primitive than Authorizer, as this is the driver that will be running whenever the SecureDock is being used. All that needs to be known about SecureDock is that it keeps the COM port open for input-output byte buffers. Let's see it in action. First, the user plugs in their SecureDock to an internet-ready machine. The user enables the SecureDock driver, and then enters their PIN code. They are now connected to their real web workspace. As long as the SecureDock is connected, the user has full access to their real web dashboard. Once the device is removed from the machine, that profile is locked and cannot be accessed. This is achieved by generating the dashboard source server-side.
We would now like to present a real-world situation in which the SecureDock is utilized. Say, for example, an organization in New York needs to grant access to a work group in Los Angeles. Using SecureDock, a work group administrator may authorize the access to the Los Angeles-based work group by running SecureDock on their local machine in New York. Any user that is in this work group will have access to the workspace as long as the SecureDock is connected and running. As soon as the hardware is disconnected, any user in that work group, wherever they may be geographically located, will be locked out of the system. This is beneficial to organizations who distribute projects externally.
The SecureDock microcontroller software consists of 9 essential M modules: main, notifier, serial port, secure timer, vault, LED, keypad, EEPROM, and buzzer. In order to allow for hardware modifications, each essential part of the system is built into its own module. This way, hardware can be interchanged with only minor changes to the software.